Assalamu alaikum warahmatullahi wabarakatuh. Hello my dear students. My name is Mr. Ahmed Munir and today inshallah we are going to talking about a new lesson. But before that, don't forget to make like, share, subscribe, put your comments, and now let's go. Vectors, as we studied before, we must be to have two conditions to say we have vector. What about these two conditions? Yes, that's right, exactly. The two conditions, number one is magnitude, that's meaning a number. And condition number two, it's going to be what? Yes, it's directions. And we know for any ordered pair in the Cartesian graph, x-axis and y-axis, this is x-axis and this is y-axis. As we studied before, any points in this Cartesian graph, we must be to have, yes, ordered pair. Any points here, if we say this is point of A, that's meaning we must be to have x and y. The first number or the first projection is x and second projection is what? Is y. So for any points here, for any line, we are going to draw it from the origin point to this point A. This is called starting from origin point. This is O or 0. This is origin points and A, the point A is x and y. So this is called what? Yeah, it's called the directed line segment. So OA is called line segment. And by the way, now we're going to say it's a vector of OA. And now O, the vector of OA, is going to be x and y. And by the way, this is the first method to say the position of vector. So the first position to represent any vectors is called vector. And position vectors, that's meaning we are going to determine here by using its ordered pair. So in this opposite figure, for any points here is A, this is OA is called, this is vector is called the vector of OA. And by the way, as we said now, this is the position of vector A. We have a point A is going to be 3 and 2, and point B is going to be -3 and 4. Now we have two vectors. The first one is O till point A, and second one from O to B. This is two vectors. If we need to denote, we are going to denote or rotate by this way, because its starting point is the origin point, so we put it like this. Is going to the vector A equal, is going to be 3 and 2, and vector B, and we denote with this symbol, is going to be, yes, -3 and what? -3 and 4. Okay, well, what about now to find the distance from O to A or from point 0 O to B? To find this, that's meaning, as we said before, is called the norm of vector. To find the norm of vector, we are going to make this step. Looking here, yeah, the norm of vector by this method, the norm of vector A, for example, is going to be the square root of x power 2 plus y power 2, -3 and -4. What about now to find the norm of this vector? To find the norm of this vector is going to be, by the way, to know this is the value of x and this is the value of what? Of y. And this rule, according to this rule, the norm of vector A is going to be square root of -3 power 2 plus -4 power 2. If you put it in calculator, the answer is going to be what? 5 what is going to be 5. 5 what? 5 length. 5 length unit, because we don't know this is centimeters or meter, just is going to be 5 length unit. What about if we have another example? If vector C is going to be -3 and k, and the norm of vector C equal 3 square root of 2. Now find the value of k. Rules, the norm of vector C, its value is 3 square root of 2, is going to be square root of -3 power 2 plus k power 2. To cancel this square root, that's meaning we are going to make both of two brackets power 2. So the left hand side power 2 is going to be, yes, exactly, is going to be 18 equal, and this is bracket power 2 is going to be 9 plus k power 2. K power 2, this is positive 9, we take it to other side here to be negative 9. So k power 2, 18 minus 9 equal 9. And it means k, to get square root for both of them, square root, don't forget when we are going to get square root, the answer is going to be positive or negative what? Positive or negative 3 of the unit vector and zero vector. The unit vector here, it means if we get its norm, its vector whose norm is unity, that's meaning is one dense unit. For example here, if vector A equal 3 over 5 and 4 over 5. Now let's go to find the norm of vector A. Is going to be square root of 3 over 5 power 2 plus 4 over 5 power 2. If you get the answer is going to be 1. Don't forget length unit. So this is called what? It's called the unit vector. Why? Because its norm is equal what? Is equal 1. The same meaning of the zero vector. Zero vector, that's meaning its norm equal 0. Second method to write the vector is called the polar vector. Yeah, do you remember about the first method? Yes, the first method is called what? The position of vector. The position of vector we wrote it by using the two ordered pair, the ordered pair of the point. But this is number 2. This is number 2. It's called what? Polar vector. Polar vector here, it's going to be also ordered pair. But this is ordered pair is consists of number 1, the norm of this vector. And the first condition or second condition is going to be the theta, the angles between OX and OA. This angle is going to be the second condition. So for example, if this angle is 30 degrees, and from 0, the origin point, to point A, for example, if it's going to be 3 length unit, so it's going to be, this norm is going to be 3, and this angle here is 30, so it's going to be 3 and 30 degree. In the opposite figure, if this point is called A, and now as we started in first term, if we complete this figure to be like this part we said before is going to be what? Yes, this is the hypotenuse. The hypotenuse from O to A. This is the hypotenuse. And the hypotenuse, its length is going to be the norm of this vector. So we can say this is the norm of OA times what? Yes, times sine theta. And this part is going to be the norm of this vector times what? Times cosine theta. So by using now, this is the value of x and this is the value of y. This is the value of y and this is the value of what? Of x. Now we can put it now the position of this vector by using this one. So the vector of OA is going to be equal the norm of OA cosine theta and the norm of OA times what? Sine theta. And we must be to know this is the value of x and this is the value of y. This is, it's apart from x and this is a part of y. So because that we can cancel x. And now let's go to have example about to solve, to can it change, if you can change from the polar form to position or vice versa. Okay, let's go. I give it to the number and angle. So this is polar form. And now we need to change it to be what? By using the points. OA, the vector of OA is going to be by using x and y. And now the value of x equal the norm of vector OA times cosine theta. That's meaning the norm of this number is going to be 10 square root of 3 times cosine theta, and theta here equal 60, cosine 60 degree. If you put it in your calculator, the answer is going to be 5 square root of 3. What about to find the value of y? With the same method, the norm of vector OA times sine theta. This norm is going to be square root of 10 square root of 3 times sine 60. By using the calculator, the answer is going to be what? 15. Now, the vector A or the vector OA is going to be what? This is the value of x, 5 root 3, and 15 is going to be the value of y. The value of what? Of y. Now you can change 2 and 3 with the same method. And don't forget, this pi for angles we're using pi equal what? 180 degree. Okay? Let's go to have another things. Two vectors. Can we adding the two vectors algebraically? Yeah. If we have two vectors like vector ax1, y1 belongs to R2 and B, vector B equal x2, y2 belongs also to R2. R2 here, that's meaning for the Cartesian x-axis and x-axis and y-axis. Then the vector A plus vector B is going to be the first projection plus first projection and second projection with second projection. For example, here if vector A equal 3 and 5 and vector B equal 2 and 3, then vector A plus vector B is going to be, this x1 and this is x2. We are going to add it together. The answer is going to be 3 plus 2 equal 5. And this one, y1, and this is y2. 5 plus 3 equal 8. So vector A plus vector B is going to be 5 to 8. 5 and 8. Properties of addition on vectors. The first property is called closure property. Closure property, that's meaning if we adding any two vectors, the answer is going to be also belongs to, is going to be vectors belongs to R2. Commutative property, that's meaning if we change the places, if we make a vector A plus vector B or vector B plus vector A, the answer is going to be the same. Property number 3, associative property, that's meaning if we have three vectors, if we add the first vector plus second plus third or second plus third, after that we make it plus first, the answer is going to be the same. Identity element, that's meaning vector A plus vector 0. Vector 0 here consists of x and y, both of them is 0, and as we know, anything plus 0 is going to be the same. Additive inverse, as we studied before, the additive inverse for any number, for additive inverse, we change the sign. So if we have x and y, and we need to change it to be negative x and negative y, after that we added, the answer is going to be 0 plus 0. So it's going to be 0 and 0. Last one here, and this is it's a new one. Elimination property. If vector A plus vector B equal vector A plus vector C, by cancelled from vector A and vector A from here and here, because vector A, if we take it to the other side, is going to be negative vector A. Vector A plus negative vector A is going to be vector A plus negative vector A plus vector B is going to be vector C. We take negative to be other side here. So this is going to be 0. So it's going to be vector B equal vector what? Vector C. Okay. Let's go to have another thing. Okay. What about if we have a number before the vector? For example, here vector A is going to be 3 and 5. What about if we need to find 2 of vector A? Going to be with x and is going to be with y. The same things here. That's meaning 2 times the vector A is 3 and 5. That's meaning it means 2 times 3 and 2 times 5. 2 times 3 is going to be 6 and 2 times 5 is going to be 10. What about is of multiplying a vector by a real number? The first one is by distributive property. Distributive property, that's meaning if we have any number before the the vector, so k times, so the same things here is going to be k times vector A plus k times vector B. The same thing is if we have two numbers k1 and k2 with vector A, the same thing is going to be k times with vector A and k2 times vector A also. Associative property, that's meaning it means vector A, k1, k2, the same things. It's going, if we adding the k1 times k2 first, after that we get the answer times vector A, or we get the value of k2 and vector A together, after that we make it times with k1, the same things here. Elimination property, it means vector A and vector B and k, all of this belongs to R star, and R star, it means R minus 0, R minus 0. And k times vector A equal k times vector B, it means A equal vector B. Okay, if we have two vectors are parallel, if the two vectors are parallel, that's meaning theta 1 equal theta 2. It means theta 1 equal theta 2. Here, theta 1 equal theta 2. And it means also tan with theta 1 equal tan theta 2. Tan, if you, as we saw it before, is going to be y over x. That's meaning y1 over x1 equal y2 over x2. Because if you remember, we know sine theta, or sorry, tan theta equal opposite over adjacent. Opposite over adjacent. This is R equals, if we make cross multiplication, is going to be x1 y2 equal x2 y1. If we take this side and we put it here, it's going to be x1 y2 minus x2 y1 equal what? Equal 0, and vice versa. So if we have any two vectors are parallel, that's meaning tan theta 1 equal tan theta 2, and we can get this rule, and vice versa. That's meaning if we have these rules, it means this is two straight lines is going to be, this is two vectors is going to be parallel. What about if the two vectors are perpendicular? Tan theta 1 times tan theta 2 is going to be what? Negative 1. From the relation between the two straight lines, for the relation between two straight lines as we started in third prep. Okay, tan theta 1, that's meaning y1 over x1 times, yes, y2 over x2 is going to be what? Negative 1. Now, y1, y2 over x1, x2 equal negative 1. And we know any whole number, its denominator is 1. So, y1, y2 equal negative x1, x2. This is negative, we take it to the other side to be positive. So, x1, x2 plus y1, y2 is going to be what? To be 0. So, and vice versa. That it means if we have this rule, that's meaning this is the relation between two vectors is going to be parallel, to be perpendicular, sorry. Or if the two vectors are perpendicular, that it means we have this rule to prove vector A perpendicular with vector B, or vector A parallel with vector C. And now what about the equality of two vectors? In which time I can say vector A equal vector B. This is under the only condition if x1 equal x2 and y1 equal x2. If x1 equal x2 and y1 equal y2. If those are equals, it means the two vectors are equals. Together, the method we have it to write the vector. Number one, if you remember that, is called what? The position vector. This is number one. Number two is called the polar vector, or the polar form. The last one here is called fundamental. The last one here is called what? Fundamental. As we say, the third type to write the vectors is called fundamental unit vectors. And this is, for example, here, if we put the vector A is going to be 2 and 3. To write it by using the fundamental is going to be vector A equal 2i plus 3 of vector J. The same thing is vector B equal negative 5 and 1. The same thing, so the vector B, by using the fundamental method, is going to be negative 5 of vector I plus 1 vector J, but we didn't put 1. This is the last thing we are going to talk in together. Thank you for watching my video. If you have any comment, just text to me, keep in touch. Don't forget, like, share, subscribe. Thank you for watching. Assalamu alaikum wa rahmatullah.